I don't know what happened in my computer. It doesn't work. Okay, thank you. Okay, guys, we start. So basically today we cover the quadratic equation, but now using quadratic formula. So this is the quadratic equation we studied last class. In the last class, we solved them by square root method and completed the square. But in my opinion, the best way, the efficiency way to solve the quadratic equation is always using the quadratic formula. And this is the quadratic formula. Let's do a couple of examples to illustrate this idea very well. Example 1. Okay, suppose this equation is 18 x squared plus 2 equal negative 15. This is quadratic equation. Es obvio que es quadratic equation. The clue que give me information que es quadratic equation is this exponent. Look, when you see exponent 2 is quadratic. Okay, but unfortunately, this quadratic equation is not expressed in standard. Because standard right-hand side must be 0. You organize in descending order of the degree, 2, 1, 0. So you write, so the step 1 is always try to write the equation in standard. And in this moment, I am ready to apply the formula because I discovered that A is 18, B is 15, and C is 2. I'm plugging in that number into the formula, que es minus 15 plus and minus square root 15 squared, que es B, minus 4 multiplication by 18 multiplication by 6 is 2. Everything divided by 2 times 18. Okay, entonces I focus in the operation inside the radical according to the order of operations. And 15 squared I put in my calculator is 225 minus a multiplication 4 times 18 times 2 is 144. And when you subtracting this, the answer is 81. And the square root 81 is 9. And so far, the solution is 15 plus or minus 9 divided by 36 because 18 times 2 is 36. Okay, now, in this moment, I like so much split this in two pieces, like a minus 15 plus 9 over 36, and minus 15 minus 9 over 36. I use a double sign, plus and minus. It doesn't matter the order. And now you subtracting is negative 6. Negative 6 divided by 36 reduced in lowest term is minus 1 over 6. And this is my first solution. And this is negative 24 over 36. Again, you can reduce divided by 12, maybe, no? Divided by 12, top and bottom is negative 2/3. Okay, entonces the solution set for this equation, solution set is, doesn't matter the order, negative 1 over 6, comma, negative 2/3. To solution. Any question, guys? Confusing, clear, easy? Remember, we can use it always in this subject calculator. I suppose everyone have a calculator, no scientific calculator. In this moment, it's not strictly important, but in the other chapters, it's mandatory use a calculator. Any question, clear or confusing? Question? No? Clear? I suppose yes, no? Let's do it one more example. Please go ahead.
For the 81, when you put it on top, how come you
Too many noise. You say something about 81, 81.
Yeah, for the 81, why do
Uh-huh.
you have to why do you have to why do you have to do the square root?
Because the formula contains square root. So basically, look at the formula. Look at the formula. Look at the formula. The formula I have minus 15 plus or minus, but when I compute, the expression inside is 81. That is the reason that the next step is compute the square root 81. Okay? Do you see the formula?
Yes.
Uh-huh. Do you understand now?
Yeah.
Okay, super. Let's move on to the second example. Example 2. Example 2 is, it's similar, but bring me new complication. The complication is that we have fractions. Suppose this quadratic equation is already expressed in standard, nice, because right hand side is 0. Right hand side is 0. Good. But you can say that A is 1, B is 1/3, and C is negative 2/3. Negative 2/3. But I don't like noise, putting off microphone. The student can name is guess 917. Putting off the microphone, please. Off microphone, please.
Professor, not to interrupt you, but the app keeps crashing and many of us are getting kicked out or can't join.
Okay. Oof, too much. Okay, so nobody working using fraction because we can transformation a little bit this equation without one equivalent. It's exactly the same, but no fraction anymore. If you multiply by 3, whole thing. So you multiply the entire equation by 3. Why by 3? Because 3 is the only number that we have in the denominator. Noise, please, off microphone. It's easy. Off microphone. Come on, GU. Putting off the microphone, please. Unbelievable. Or get out immediately. Professor. Okay. Okay, guys, any technical problem, you need to solve it. Okay? So you cannot solve it, so you cannot stay in this class. Okay, this is a disadvantage of the online class. Now, so you have a bad computer and bad application to say you cannot participate. That's it. Okay, so you multiply by 3 the entire equation to say 3x squared. Because it's 1, no? Times 3 times this. 3 times 1/3 is 1 plus x. And 3 minus 2/3 is 2. And this is a new equation. This is a new equation that, by the way, is equivalent to the original equation. What is the advantage? The advantage is that we have no fraction. So A is 3, B is 1, and C is negative 2. And now you are ready to apply directly the quadratic formula. Quadratic formula, let me copy one more time. It's minus b plus or minus square root b squared minus 4ac divided by 2a. In our specific example, b is 1. This is minus 1 plus or minus square root 1 squared minus 4 multiplication by a, que es 3, multiplication by c, que es negative 2. Be careful with the sign. It's important. The sign is extremely important. Multiplication or division by 2 times 3, que es 6. Okay, entonces now I focus on the expression inside the radical. The expression inside the radical here is, look, 1 squared, que es 1, plus, why plus? Because it's minus, double minus, become positive. And this is 24, because 4 times 3 is 12, times 2 is 24. It's 25, and now you find the square root 25 is 5. Okay, so far we have -1 plus or -5 divided by 6. 2 times 3 is 6. Okay, now ready to separate into pieces. The first piece is -1 plus 5 over 6. And -1 minus 5 over 6. Ay, what is that? Entonces es 5 minus 1 is 4 over 6. Reducing lowest term is 2/3. This is my first answer. And the second is -1 and -5, -6 divided by +6 is -1. Fantastic. Solution set for this equation. For solution set for this equation, the original equation, of course. The original is solution set is 2/3 and -1. End the story. Entonces it's extremely important. When you have a fraction, you can clear the fraction, multiply the entire equation by the least common denominator. In this case, the least common denominator is obvious que es 3 because it's the only number that we have in the denominator. Any question? No? Oh, yes. Come on. No? Okay, super. Sabrina. Okay, Sabrina. Now let's move on to the next topic. Okay. Next topic. Good morning. Wow, you are late. Okay, case about. Okay, don't interrupt me. I am teaching now. Radical equation. Radical equations. Okay. This is equations that somehow involve radical. Okay, guy, I don't care. Okay. Don't interrupt me, please. Mathematics now. Okay, ese equation que contain radical. Suppose one elementary kindergarten example. Example 1 is square root radical 2x minus 1 equal 1. Okay, super. Entonces, what is the key idea? What is the key idea in the radical equation? The key idea in the radical equation is suppose you have a square root. Entonces in order to eliminate the square root, you square. Okay. So suppose you have, for example, cubic root, you raise to the cubic power. And when the situation happens, a square root and a square cancel out each other. And cubic root and cubic power cancel out each other. Okay? Okay. This is the key idea. The key idea is, suppose you have a square root. I want to copy again the equation. I want to explain why I copy again. Now you square both sides. Noise. I cannot teach you with this noise. Please, you are noise. I'm not student. Noise. Please, putting off microphone. Well, okay, Kevin. Okay. Si you cannot participate, I posted this in YouTube. Ay. Unbelievable. This class is very, very complicated. Okay, entonces square root and square cancel out each other. Entonces 2x minus 1 equal and 1 square is 1. Noise. Get out as soon as possible after you fix it out. Es Kevin, no? Kevin, off microphone. Okay, super. I like so much of this. Okay, now In this moment, it's easy to solve for x. The 2x is equal 1 plus 1, because I move that one to the right-hand side. 1 plus 1 is 2. Divided by 2, x is equal 1. But the most important moment now is, this is my solution. However, I need to check it mandatory, and the radical equation, you have to check in the potential solution into the original equation in order to verification that this solution work or doesn't work, because sometimes it doesn't work. Okay, this is classical problem in radical equation, but it's easy. You check for x equal 1, plugging in here and the original. So I need to prove somehow that 2 times 1 minus 1 should be equal 1. I claim this statement because I don't know if it's true or false. It's obviously true because 2 times 1 is 2. And 2 minus 1 is 1, and the square root 1 is 1, and 1 equal 1. This is true. This is true. Therefore, this solution works perfectly. And the solution set for this equation is just 1. Okay, this was a straightforward example, no? But I promise that now I want to illustrate another more complicated, in which you see surprise. Okay, look. Example 2. Example 2 is square root x plus 8 plus 12 equals x. Again, Kevin, make a noise. Wow. Okay. Kevin, you make a noise. Okay? Because I recommend that you get out. And you watching the lecture in YouTube, because I will post it immediately when I finish. Okay? Please. Okay, this is very, very interesting. Pay attention, guys. Focus it. Forget about noise. Okay, the first thing you should do is isolate the radical. Okay, let's do it. I move 12 to right-hand side, like a minus 2. In this moment, you square. Why you square? Because a square allow me eliminate the radical. Wow. Therefore, we have x plus a without radical, because a square and a square root cancel out each other. And you have now the multiplication x minus 12 and x minus 12. Okay, you foil. Multiplication to binomial foil. X times x squared. X times negative 12 and minus 12x. 12 minus 12 times x is minus 12x again. Minus 12 times minus 12 is plus 144. Okay. So at that moment, I realized that we have a quadratic equation. What is the clue that give me information this quadratic equation? These two. Quadratic equation. Of course, I need to manipulate a little bit. For example, x plus a is equal x squared minus, combine like term, minus 12 and minus 12 together is 24, negative 24x plus 144. And now, I move everything to the one side. Remember, because in the standard form of the quadratic equation, right-hand side or left-hand side, doesn't matter. Should be 0 or must be 0. So in this case, I propose you, for example, this stay, but I move minus x and a to the other side. Change the sign, minus x, minus a. And here we have nothing, and nothing is 0, no? So it's x squared, and we combine like in this case 24, and 1 is 25, and 144, and negative a is positive 136, equal to 0. And this is my quadratic equation, elegant quadratic equation. Okay, how you solve the quadratic equation? Well, using the quadratic formula, no? Quadratic formula. A is 1, B is negative 25, and C is 136. Okay, I copy again the quadratic formula, minus B plus and minus square root. Very important, guys, quadratic formula. B squared minus 4AC divided by 2. Divided by 2. In our specific example, it's 25. Look. B is negative 25. The formula have a minus, and double minus become positive, no? It's a plus and minus, square root, negative 25 squared, minus 4 multiplication by 1 is a multiplication by 136. Okay. Everything divided by 2 times 1. Okay, 2 times 1. Wow. 2 times 1. 2 times 1. Okay, so we focus always the same in the expression inside the radical. Okay, we compute that part. And you put negative 25 in your calculator, no? 620. Again, the noise. Come on. Who changed the background? Who changed the background? Who changed the background? I don't want this background. Okay, I'm believing this class. Okay. Now multiplication 4 times 1 is 4 times 136 is 544. 544. And when you're subtracting, it's 81. And when you compare square root 81 and 9. Okay, so far we have 25 plus or minus 9 divided by 2. Okay, super. I split, as always, in 2 pieces, 25 plus 9 divided by 2, and 25 minus 9 divided by 2. 25 plus 9 is 34. And 34 divided by 2 is 17. Okay, this is my first potential solution. And 25 minus 9 is 16. And 16 divided by 2 is 8. And that's it. I gotta go. I finished? No. Why no? Because mandatory in the radical equation, checking. Checking who? Checking 17 and 8 into the original equation. I want to copy the original equation again. Look at that. Original equation was x plus 8 plus 12 outside the radical should be x. This is my original equation. I need to check. Check. For x equals 17, I split the paper in 2 parts and check it for x equals 8. Okay, let's do it. And verification that both are true or no. I don't know. Surprise. Square root 17 plus 8. So you replace 17 in x plus 12 should be, I claim this is statement 17. Likewise, square root 8 plus 8 plus 12 should be claim 8. Let's see. 17 plus 8 is 25. Square root 25 is 5. And 5 plus 12 obviously is 17. 17 is equal to 17. Super true, super nice. Therefore, 17 is solution. Good. Pass. The checking. The second, 8 plus 8 is 16. And the square root 16 is 4. And 4 plus 12 never is 8. 16. 16 is equal to 8. This is a contradiction, totally false. This was true. That means that the solution 8 doesn't work. And the only solution for this equation, solution set, is 17. Do you understand very well this? Guys, I promise in the review package, we go over again. Yeah, Sabrina, I said yes. I promise, guys. in the review package, I go over again to this, doing at least 2 more examples of the radical equation. Okay?
I have a question.
Please go ahead.
For the last part, why did you put 0 equals in front of the equation? Like more above, go up a little bit?
Yeah. Okay, good.
Yeah, right there where it says 0 equals x squared minus 24x, down.
That part?
Yeah.
Good. The idea is, I realize that this equation is quadratic equation. Do you understand why? Because you see exponent 2. And remember, to solving any quadratic equation, we need to express it in a standard form. Like that. This is a standard. To be ready to apply the quadratic formula. That is the reason in this manipulation, there are many ways to do that. When we combine later, but I move everything to the right-hand side in that case. Now I combine later, yeah, I get this. This is nice equation, que es equivalent, no? But it's nice to apply directly the quadratic formula. More clear now? More clear? Excellent. Excellent. Very well. Okay. Okay, entonces, I promise in the review package, we go over again to the radical equation, at least 2 more examples. Pero no super big deal, sino similar to the test. Okay, let's move on to the another important equation, another, que es called quadratic in form. This is a equation that actually is not quadratic, but we can convert to quadratic. Let me explain. Suppose this example, example 1, is 3x to the 4th power minus 2x to the 2nd power minus 1 equal to 0. Wow. Well, actually, this is not quadratic equation because the degree of this equation is 4. Remember, degree is a higher exponent. Therefore, it's a polynomial equation, degree 4. And in algebra, when you have degree 4 polynomial equation, we have 4 solutions. 4 solutions. So when you finish this problem, we get 4 solutions. But this equation is also quadratic form. How do you know that? Well, the reason is clear, because we have 2 exponents. Let me show you. You have 2 exponents. Look, exponent 4 and exponent 2. And when this situation happens, see, the greatest exponent is 4 is twice, 2 times the smaller exponent to this quadratic form. So the only condition that we need to identification that one equation is quadratic form is that we have 2 exponents. And the greater exponent is 2 times the smallest. In this case, good, very good. Now, to simplify the thing, again the noise. To simplify the thing, I appreciate so much that you don't change the background. No, next time. I don't like this background. I put my own background. Okay, thank you. Okay. Okay. Entonces, in order to convert this equation in quadratic equation, look, this is the most important moment. You define one auxiliary variable, okay, I want to call u, is equal x squared. So you, instead of working with the original variable is x, no. I substitution, this is substitution. And you define u is equal x squared, and you see what happened when you are doing this substitution. Surprise, 0 is equal -1. This is minus 2u, because by my own definition, u is x squared. You take this, but this is twice, and this is twice, this is 3u squared, because the exponent is 2. Now, this blue equation is actually quadratic equation, and you solving exactly the same we are doing before. using quadratic formula, maybe. Entonces, I discover que A es 3, B es -2, and C is -1. And you apply again the quadratic formula. Quadratic formula minus B plus or minus square root B squared minus 4AC divided by 2. En our specific example, B is -2, double negative again. Frequently happen that situation. Entonces 2 positive plus or minus square root minus 2 squared minus 4 times A, que es 3, times C, que es -1. Divided by 2 times 3. Okay, let me make a zoom. And we focus in the expression inside the radical. So I want to compute first, according to the order of operation, this expression. Okay. -2 squared is 4. It's obvious, no? Any negative quantity, when you square, become positive. And here, be careful, double minus, become positive. Positive 12. Positive 12 because it's 4 times 3 times 1, no? It's positive 12, and when you adding is 16, and square root 16 is 4. So far, we have 2 plus or minus 4 divided by 6. Que es the multiplication 2 times 3. Now you separate into pieces. Que es 2 plus 4 over 6 and 2 minus 4 over 6. Well, 2 plus 4 is 6, and 6 divided by 6 is 1. Okay, super. And 2 minus 4 is -2, and -2 divided by 6 is, well, in lowest term. You need to express the answer, the final answer, in lowest term. Okay, be careful, because maybe in my test is okay, I understand. However, in Alex, when you are doing the homework online or the test online, see, you leave it like that, one answer, Alex don't understand. So you need to reduce in lowest term, you divide it by 2, top and bottom. It's -1/3. Okay, this is my final answer. No. Why no, professor? Because this is U value. Remember the story. The story is we have original equation, is degree 4, polynomial, 4 solutions. I do something, substitution, I convert to quadratic in blue color, and quadratic is solving, I obtain 1 and -1/3, but this is U value. So U is equal 1, and U is equal -1/3. I split the paper again in 2 parts. But I need to find no U value. I need to find X value. To say X, the relationship between U and X is X squared. Remember the substitution I did before. Look here. This is the formula that states the relationship between U and X. Okay, it's easy. So X squared equal 1. And X squared equal -1/3. Entonces, in this moment, right now, I have two quadratic equations. This is a quadratic equation, and this is another quadratic equation. But this is easy quadratic equation that you can solve it using square root principle, square root method. Okay. Entonces, this is X equal, don't forget, plus or minus 1. And here is X equal plus or minus, but in this case, imaginary, because when the number inside the radical is negative, it's I, radical 1/3. Entonces, this is acceptable. However, in this case, we can simplification a little bit. I suppose you remember, this is a fraction. Entonces, when it's a fraction, it's a square root the top over the square root the bottom. But this is plus or minus I, but square root 1 is 1, and square root 3 is square root 3. You can leave it like that. This is just cosmetic part, and you can rationalize. This is classical in algebra, rationalization. Multiplication by radical 3, so X is equal plus or minus I. 1 times radical 3 is radical 3, and radical 3 times radical 3 is 3. Okay, this is the super elegant. However, if you leave it like that in the test, or like that, it's acceptable. At least for me. And Alex, no. So what is the final answer? Well, the final answer is solution set is we have 4 solutions, no? It's expecting plus or minus 1, comma, plus or minus I radical 3 over 3. Now we have 2 real solutions, plus or minus 1, and we have 2 imaginary solutions, is plus or minus I radical 3 over 3. Any question? Any question? We are doing...
I have a question.
Go ahead.
Yeah. Are you writing U's or Y's? I can't really tell.
Using what?
For the variables, I know you're writing X and something else. Are you writing Y's or U's?
No, you. This is you. But okay. You using either. You're using one auxiliary variable. The most common auxiliary variable in mathematics is U, W. But see you using Y is possible. So this is just a variable, just a letter. The most common use in mathematics is U, number 1, and W, number 2. And Y sometimes. Okay, another question. Do you understand the procedure? Okay, this equation, I promise that we see frequently this kind of equation throughout the course. Quadratic Form equation, some people interrupt me. Okay, let's move on to another very, very interesting equation.
I have a question. I'm sorry.
Go ahead.
For the one where it says u equals negative 1/3, like the way you solved that one, can you please explain it again?
Okay, bueno. Okay, in this case, it's radical 1/3. Forget about plus or minus I. This is totally not irrelevant, but this is not the thing you want to see, no? You say, I can simplification. You can. How? This is a fraction, and you separate square root 1 over square root 3. This is good for you? This is a property.
Yes.
When you have square root A over B, this is equivalent to square root A divided by square root B. Now, square root 1 is 1, and square root 3 is like that. And this is elegant, super elegant solution, but much better. This is super cosmetic. Rationalization. Rationalization means that you eliminate the radical and the bottom always. So you multiply by radical 3 gets the same number, no? The 1 times radical 3, and radical 3 times radical 3 times radical 3 is radical 9, no? Pero radical 9 is 3. Okay? This is 3. End the story. These and these are equivalent. This is more elegant. This is not elegant. But it's just cosmetic. So you don't manipulate, I don't care. This is not important. This is totally irrelevant. Clear, miss?
Yes, and also, how come you put the I on the other? Like it says,
Yes.
like you put the I in front of the fraction.
The reason is que in that part we have a square root negative 1/3. And you know that when the number inside the radical is negative, you have I and square root 1/3. And the rest you know. But I is mandatory because it's negative. So square root negative any number is equal I square root the same square root of the positive number. Do you remember this formula, no? That we studied in the first class, no?
Yes, I remember. So you keep the I in the answer always?
Absolutely.
Okay.
Look at that. Look in the solution set I write here. Solution set. Ooh, plus or minus I radical 3 over 3. So this is real solution, and this is imaginary solution. Imaginary solution. Any other question?
Thank
Super.
you.
Good, very good. Let's move on to another example. Another example of the quadratic form. Remember, quadratic form is a special equation that you frequently can see throughout the course, I promise. And you actually, the equation is not quadratic, but we can convert to quadratic using U substitution. Example 2. Example 2. Suppose x raised to the 2/3, wow, fraction exponent, minus 7 x to the 1/3 plus 10 equal to 0. Suppose in the test I put something like that. My question is, this is quadratic form equation. Yes or no? No? Yes? No? Yes?
Yes.
Yes! How do you know? How do you know? How do you know? Sabrina, how do you know?
Because of the exponents and it's equal to 0.
Say again? Because?
Because it's equal to 0 and you have the exponents.
What happened with the exponent? Explain me that part more clear. You have two exponents.
Yes.
This gets 2/3 and this is 1/3. What is the relationship? What is the connection in between these?
The denominator is 3.
Yes, you're right. But this is not the important part. The important part is twice, 2 times. So 1/3 multiplication by 2 is 2/3. So when you have, let me repeat again the idea. You have two exponents, bam, bam, bam. But when the higher exponent is twice the smaller exponent, this is the clue of the identification of quadratic form. Okay? Now, let me try to do U substitution. U is equal x to the 1/3. So I always use it for the substitution, the smaller exponent, the smaller. So 0 is equal 10 plus -7. This is U, my own definition, and this is U squared. Do you understand this idea? Because this guy is twice this guy. So you define que this, let me use another color. Suppose que you define que this green part is my U. This is U squared. Make it sense or no? Make it sense or no? No? Confusing? Am I honestly?
I'm confused. Can you like
Okay.
explain it more?
No, of course. Explain anytime that you need. Okay. Suppose que x to the 1/3 I call like a U. This is my definition. Why I do that? Because in order to solve this equation, I need to convert to quadratic equation. Suppose que you square both sides. Square. You know, I suppose you remember the rule of the exponent. When you square, you have two different exponent multiplication each other to say x to the 2/3, because I suppose you know that 1/3 times 2/1 is 2/3, no? Is equal U squared. That is a reason que in my definition, if U is x to the 1/3, que está par, okay, then U squared is equal to x to the 2/3, que is that part. More clear now? Yes or no?
Yes.
Absolutely. Okay, super. Now, this blue equation actually is quadratic equation. We can solve it using quadratic formula. Or in this case, I recommend using the factorization because it's too easy. That the factorization is too easy. In that case is UU and the combination of 5 and 2, no? Because 5 times 2 is 10 and 5 plus 2 is 7 and negative both. Guys, suppose if you are not strong, in the factorization. Okay, I understand. And we can solve it by a quadratic formula. You get exactly the same answer. What is the only disadvantage is que quadratic formula is a little bit long and factorization is too super fast when you see the combination, right? So in this case, u minus 5 is equal to 0. U minus 2 is equal to 0. Therefore, one solution is 5 and one solution is 2. And that's it, no? Of course, no, because remember, this is u value. I need to express the final answer using x value, get the original variable. So you split the paper into parts. And who is u? Well, u is x to the 1/3. X to the 1/3 is equal to 5. And x to the 1/3 is equal to 2. Maybe it's confusing the fraction exponent, but don't worry, don't worry. I want to explain in detail now. Look, fraction exponent is equivalent to the radical notation like that. These three represent the index of the root, and this one represents the power. I suppose you remember this. You remember or you don't remember? Conversion, fraction exponent to radical notation. Likewise, here is cubic root x equal to. Either way, we can do that using this idea or using this idea because it's the same, right? So in this moment, we have two radical equations. This is radical equation, remember the key idea for solving any radical equation is in this case, raised to the cubic power because the index is 3. Cubic power. And cubic power and cubic root cancel out each other, and it's x equals 5 to the cubic power, and 5 to the cubic power is 5 times 5 times 5, 3 times. But not 5 times 3, it's 5 times 5 times 5, 5 times 5 times 5, or you put in the calculator, is 125. And likewise here is 2 times 2 times 2, que say. And this is the answer. The answer is x equals 125 and x equals 8. And that's it. No, that's it. No, professor. Because you told me that when you manipulate radical equation, you need to check it. Okay, in this case, no necessary checking. No checking. When the index of the root is odd number. Suppose radical equation can involve cubic, fifth, 7. Okay, the index is odd number, no checking. Only checking when the index is even. Square root, you know, the square root, the index is 2, que default, you suppose que es 2, 4 root, and so on. When it's even, yes, you have to check it. Mandatory checking. Otherwise, when it's odd, no. No, yes. Okay, in this case, the solution set is 125 and 8. Final answer. Super. Let me try. We have only 2 minutes. But let me, any question, guys? Do you understand very well or no?
Sir, are you going to keep on? Oh, bad.
One by one. Come on, the lady first. Come on.
I'm just having trouble with the, like, when you put the 3 where the square root is, and then outside, and then you put it to the other number where it says equals, because you put it for the x 1/3 and the x 1² too.
Okay, you need to know x to the 1/3 power is equivalent or is the same to the cubic root of x. Do you understand this idea?
Yes.
Super. And our specific example, this is 5. In order to isolate x, so I need x, I need to remove everything into the solve for x. You raise to the cubic power here, raise to the cubic power here, and raise to the cubic power here. This is the key idea always in radical equation, because this allows us eliminate the radical. And cubic root and cubic power is 1. Look here, it's much better to see maybe in fraction. 1/3 times 3 over 1 is 1, because it's 3 over 3, no? Que es 1. Entonces, this is 1, que es invisible exponent, not necessary to write, equal 5 cubic. And 5 cubic is 125. More clear now?
Yes, it's better. Thank you.
Excellent. Sir, your question?
Yeah, I just want to know if you were going to keep on using Skype because a lot of people are getting kicked out.
Okay. Okay, guys.
Oh, wait. Sorry, I have a question about the one where it says, because I understand when it's a cubic root, but there's the one that says x to the 1/2. How come you did the cubic root for that one?
Okay. Suppose, this is the next example, but let me try to explain. Suppose que es x to the 1/2, no? Equal 4, for example, no? This is equivalent to say square root x equal 4. Because these two, que the index represent these two. Okay, by the way, in square root, the index is invisible. But it's the same. You square both sides. Here, exactly the same. The student can prefer working with the fraction exponent, it's okay. The student can prefer convert to the radical to see much better, it's okay. Entonces, you know, que in that part, let me try that part. A square root and a square power cancel out each other, and the answer is 16. Okay? Like why here, so you manipulate in this way, it's x to the 2 over 2, okay, 1, equal 4. Square is 16. Therefore, x equals 16. We get the same conclusion. More clear now?
I understand that one, but on top when you did it, it says 1/2 and you did the cubic root.
Well, okay, because depending the index of the root. In this case, in this example number 2, the exponent is fraction whose denominator is 3. That is the reason that we are working in specific, in this example, with the cubic root. But see, the exponent here, I change, like the example I try to do, but I have no time, que es 4 here, and 2, entonces square root. It's different, right? Depending on the problem. Okay, guys, entonces now, remember, Monday, no school. I don't want to send any link, any link for the Skype connection. And right now, I will post it in YouTube, this video. I send to you email. The student cannot participate in the Skype. You can see at home again. Okay? Super. Any question? No problema. Okay.